Hey everyone, welcome back. This is lesson 6-2, Multiplying Polynomials. Here you see Blaise Pascal and Sir Isaac Newton. These were both famous mathematicians and philosophers. And in today's lesson, you'll see a triangle that's named after Blaise. He worked on what is called the Pascal triangle. It's very useful in mathematics. Also, Sir Isaac Newton, among many other things, he discovered what we call the binomial theorem. And so you're going to be hearing a lot about that in this lesson also. So let's get going. All right, the objectives for today, you're going to be able to multiply polynomials, and you're also going to be able to use binomial expansion to expand binomial expressions that are raised to positive integer powers. So let's see what that means. To multiply a polynomial by a monomial, you're going to use the distributive property and the properties of exponents, which you've already learned. All right, so let's try this example. It says find each product. So really all we have to do is distribute our 4y squared. So we're going to go ahead and do that. Say 4y squared times y squared, and then distribute it to this next one, plus 4y squared times 3. Now we just have to multiply and simplify, so it's going to be 4y to the fourth plus 12y squared, and that's all you have to do and you're done. All right, the next one looks a little more complicated, but nothing big. Again, we're going to distribute that fg to everything. So fg times f to the fourth plus fg times 2f to the third g minus fg times 3f2g2 plus f, I'm going to go ahead and distribute that one, fg times fg to the third. All right, so again, we just have to go ahead and simplify this. f1 and f4 is f5g plus 2 times f1 and f3 is f4, and g is g2, plus a negative fg, let's see, let's clear this up a little bit. Let's just say minus. Minus, we have a 3. We have 1, 2, 3 f's, so f to the third and 1, 2, 3 g's. All right, and then plus, here we have 2g f's, f2, and 4 g's, g4. And there is our final answer. All right, try 2 on your own. Go ahead and turn your video off and give it a try. All right, once again, all we have to do is distribute. So we're going to distribute our 3c to everything. 3cd squared. 3cd squared times 4c squared d. Again, there's a bit of minus in there. 3cd squared times 6cd. And one more time, plus 3cd squared times 14cd squared. All right, so now that we have all of that, we can just go ahead and get all of our terms together. 3 times 4 is 12. 1c and 2 c's is c to the third, and 2 d's and 1 d is d to the third. All right, negative 3 times 6 is a negative 18. We have 1, 2 c's, and we have 3 d's, d to the third. Plus 3 times 14 is 42. And we have 1c and 1c, so that's c squared, and 2 d's and 2 d's, so that's d to the fourth. And there's your answer. Not very difficult. Hope you got that one. Again, we'll just distribute this x squared y to everything. X squared y times 6y to the third plus x squared y times y squared minus x squared times 28, x squared y times 28y, and then plus let's do it one more time. X squared y times 30. So when we work this out, we have 6, we have x squared, and 4 y's. Y to the 4th. All right. Next we have x squared and 1, 2, 3 y's. Y to the 3rd. Here we have a negative 28. We have an x squared and y and a y, so we have 2 y's, y squared. And finally, we have a 30x squared y. There we go. Okay, let's keep going. All right, to multiply any two polynomials, use the distributive property and multiply each term in the second polynomial by each term in the first. So all we have to do is we're just going to distribute. We're going to say x times x squared, x times 4x, and x times negative 3. And then we're going to go ahead and distribute our 2 times x squared, 2 times 4x, 2 times negative 3. So keep in mind that if one polynomial has m terms, all right, and that, let's just say our first polynomial here has m terms, which is, we have 2 here, and the other has n terms, so we see that this has 3 terms. Then the product has m times n terms before it's simplified. So 2 times 3 is 6. So let's see if that's what that looks like really. So our 2 times x squared is going to be 1 term, 2 terms, 3 terms, and then going the other way, 4 terms, 5 terms, 6 terms. Okay, so if you count 6, then you know you got it right if you've counted them up. Sometimes when it gets big, it gets kind of messy, so it's nice to know how many terms you should have. Of course, you will then simplify, and sometimes this number will go down. So that's all you need to know about that. So here's an example. Let's find the product of this. The first thing we should do is go ahead and write the polynomial in standard form. That just means that the exponents are listed in order from greatest to least. So now all we have to do is go ahead and distribute our distribute here. So we're going to take a times a squared is a to the 3rd. Multiply a times negative 5a, so that's minus 5a squared. Multiply a times 2, so that's going to be plus 2a. Next, we're going to go ahead and distribute our negative 3. Negative 3 times a squared is going to be plus a negative 3a squared. Negative 3 times negative 5a is going to be positive 15a. And negative 3 times 2 is plus a negative 6. Now we can go ahead and see if we have any common terms, which we do. Our a to the 3rd is just going to say a to the 3rd. We have a negative 5a squared and a negative 3a squared, and that leaves us with a negative 8a squared. Positive 2a plus positive 15a equals a positive 17a, and then we have our negative 6 minus 6, and there's your final answer. All right, here's an example for you to try on your own. Turn your video off and give it a try. All right, so hope you found that to not be too difficult. Let's just check it. First thing you want to do is write your polynomial in standard form. It's really not that big of a deal. It's just a formality. If you do it, great. If not, you're not going to get counted off for that. So here we go. All we have to do is distribute. First, we're going to distribute our 3b. So I'm going to say 3b times 3b squared. So it's going to be 9b cubed. All right, next I'm going to multiply my 3b times a negative 2c squared. So that's going to be plus a negative 6bc squared. And then I'll multiply my 3b times a negative bc. So it's going to be plus a negative 3b squared c. All right, next I'm going to distribute my negative 2c. Negative 2c times 3b squared is plus a negative 6b squared c. All right, negative 2c times negative 2c squared is going to be a positive 4c cubed. And finally, negative 2c times a negative 1bc is actually a positive 2bc squared. All right, so let's just gather up all of our terms together. I'm looking for another b to the third. I don't see anymore, so my first part of the answer is 9b to the third. The next thing I'm going to gather up is my b squared c's. So b squared c, here's one, and b squared c, here's another one. So negative 3 plus negative 6 is a negative 9, b squared c. Next, I'll gather up my negative 6b c squared, and here's a bc squared. So that's negative 6 plus positive 2 is a negative 4. Negative 4 bc squared. And that leaves me with just my 4c cubed left, and that's our answer. That's not too difficult. All right, this example is just an extension of what you've been doing. This time, though, we're going to just take this term, a plus 2b, and we're going to cube it. This means we're going to just write it out 3 different times. So write it in expanded form is going to be a plus 2b times a plus 2b times a plus 2b. So what we want to do first is just go ahead and let's multiply these 2 terms together. And again, we're just going to be doing it by FOIL. We're so used to that. A times A is A squared. A plus 2B is plus 2AB. And then 2B plus A times A is another plus 2AB. And then 2B times 2B is plus 4B squared. All right, and let's get our common terms together. 2ab and 2ab leaves us with a squared plus 4ab plus 4b squared. And now all we have to do is multiply by a plus 2b, our last term. All right, so again, we're just going to distribute. Let's start out with our a. A times a squared is a cubed. A times 4ab is plus 4a squared b, and a times 4b squared is 4ab squared. All right, now we're going to distribute our 2b. So 2b times a squared is going to be plus 2a squared b. 2b times 4ab is going to be plus 8ab squared, and then 2b times 4b squared is going to be plus 8b cubed. All right, so once we have done all that, we're put all of our terms together. We have an a to the third, so we're just gonna, don't have anything else to match that. All right, let's look here. We have a 4a squared b and a 2a squared b, so that's going to be plus 6a squared b. Now we have 4ab squared and 8ab squared, so that's plus 12ab squared. And then the only thing we have left is plus our 8b to the third. So there's your answer. Not anything different, it's just the same thing we've been doing, just a little bit more expanded, more of it. All right, here's another one for you to try on your own. Go ahead and do this one. Turn the video off and give it a try. All right, again, the first thing we want to do is to write it in expanded form. So 2x minus 1 times 2x minus 1 times 2x minus 1. And then we're going to multiply our last 2 binomials together. And when we do that, we just FOIL that. 2x squared is 4x. 2x times 2x is 4x squared. This is going to be minus 2x and another minus 2x, so that gives us minus 4x. And then negative 1 times negative 1 is a positive 1. So there's our FOILed out. And now all we have to do is go ahead and distribute. First, we're going to distribute our 2x. And so 2x times 4x squared, 2x times negative 4x, and then we'll distribute our negative 1. Negative 1 times, oh, I'm sorry, I forgot my 2x times 1. 2x times 1, there it is. Okay, and then negative 1 times 4x squared, negative 1 times 4x, right here, and then negative 1 times positive 1 is right here. All right, so once we've done that, we just multiply everything out. Pretty simple. 2 times 4 is 8x to the x third, to the third power. 2x times negative 4x, negative 8x squared, and so on all the way down. All right, then when we combine all of our terms, notice I just have one 8x to the third. But as far as x squared goes, I have a negative 8 and a negative 4. So that's negative 12x squared. And then my x's 2 and 4, so that gives me a 6x and then a negative 1. So there's your final answer right there. Here's one for you to try on your own. Turn the video off and give it a try. Okay, hope you didn't have very much problem with this one. The first thing we want to do is just go ahead and expand it all out. So that just means x squared, x plus 4 times x plus 4 times x plus 4 times x plus 4. Once we've done that, we want to multiply, and I wrote the first two, but I actually multiplied the last two binomials together. So when I distribute x squared plus 4x plus 4x plus x to the plus 16, gives me x squared plus 8x plus 16. And then I'm going to do the same thing with our other two factors. I'm going to go ahead and distribute on that, FOIL that out. And we end up with x squared plus 8x plus 16 and x squared plus 8x plus 16. Now it's going to get pretty long here. So what we're going to have to do is going to distribute our x squared. We're going to then distribute our 8x. And then we will distribute our 16 to everything. Okay, so let's just go ahead and get started. I'm going to go ahead and have the answers out here for us, but I'll just do it by hand for a minute. So x squared times x squared times 8x, and x squared times 16. Next, we're going to go ahead and distribute our 8x times x squared, 8x times 8x, and 8x times 16. And then finally, we're going to distribute our 16, and that gives us 16 times x squared, 16 times 8x, and finally 16 times 16. Okay, now the next thing that we need to do is just get our like terms all together. We see that we have, actually I did the multiplying first, and there it all is. So x squared times x squared is x to the fourth. The next one is x squared times 8x is 8x to the third. This is going to be 16x squared. 8x, that's 8x to the third, and so on all the way down. So you can see, you just multiply them together. And now all we have to do is add up our like terms. Notice that there's only one x to the fourth. And so let's just combine all of our like terms. We have for our x thirds, we have 8x to the third and an 8x to the third, so that gives us 16x to the third. For our x squared, we have 16x squared plus 16x squared, that's 32x squared, plus 64x squared gives us 96x squared. Finally, 128x and 128x is 256x, and finally our 256. So I hope that you were able to get those big numbers even though it was kind of large. Okay, so let's put up this problem again, and here's this long answer of x plus 4 to the fourth power, and this is where our friends Blaise Pascal and Sir Isaac Newton come in handy here, and Newton, for instance, was working for a university, Trinity College in Cambridge, England, and the college had to close down because of the plague. So Sir Isaac Newton was able to spend an extra amount of time just working on his math and all alone. And he was looking at some problems like this and also some problems like, say, 2 plus x squared, which we know to be 2 plus x times 2 plus x. And so when we work that out, it would be 4 plus 2x plus 2x plus x squared, 4 plus 4x plus x squared. So he was looking at some problems like this and problems like this and things to the third, and was wondering, is there any kind of a pattern here, anything that can make this go faster? Because each time we do this exponent, it gets exponentially more complicated and difficult. And so he actually came up, as with Pascal, came up with a thing called binomial expansion. This was what Isaac Newton's contribution was. And as he was looking at this, he realized that, okay, a plus b to the 0 power is just going to be 1, because anything to the 0 power is 1. And a plus b to the first power is simply itself, a plus b. But then it gets a little more interesting here. A plus b squared ends up being a squared plus 2ab plus b squared every single time. And so when we look at an equation like 2 plus x, and we see that this is our a and this is our b, we can see a squared, well, 2 squared is 4. And then it says plus 2ab, well, a times b is 2x, and if we multiplied that by 2, that would be 4x. So here's our second term, and then with our b squared, b was x, and so that's how we got x squared at the end there. So he started looking at these patterns, and then let's look at our 4x plus 4 to the 4th power. Again, if this is our a and this is our b, we see our first term was x to the 4th, and so that's the a to the 4th. And sure enough, when we look at something in the 4th power, a to the 4th is our first term. The next term is a to the 3rd, and so that's x to the 3rd times our b times 4, and the b was 4 times 4, so that gives us our 16 x to the 3rd. And then our next term, we see 6a squared b squared. Well, a squared is going to be x squared, so there's our x squared. And then it says take b and square it. That'd be 16, and multiply it by 6, and that happens to be 96. And then he said, okay, for the next term, we've got 4ab to the 3rd. Well, b to the 3rd is 4 times 4 times 4, which is 64. And then it says multiply it by one more 4, so that gives us 256, but there's only one a, which is one x, so there's our x. And the last term is just our b to the 4th, which is 4 times 4 times 4 times 4, ends up being 256. And he just discovered that there's this little pattern here, and it just continues on and on. And at the same time, Pascal begins working on this triangle, basically around the same time. And he realizes that there's actually a pattern here going on. And so he works with this triangle, which we now call Pascal's triangle. And basically, we start out with 1 at the top, and then 1 plus 0 is 1, and 1 plus 0 is 1. But then look here, 1 plus 0 is 1, 1 plus 1 is 2, and then the 1's come back down. 1 plus 0 is 0, because there's nothing on the other side. And then again, 0 plus 1 is 1, 1 plus 2 is 3, and 2 plus 1 is 3, and then our 1's come straight down from 0, adding 0 again. Then we come on down again, 1's come down, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and our 1's come down. And again, 1 plus 0 is 1, 1 plus 4 is 5. 4 plus 6 is 10. 4 plus 6 is 10. And 4 plus 1 is 5. And then 1 plus 0 is 1. So this handy little chart, triangle, Pascal's triangle, is going to really help us when we're doing exponents. Binomial expansion is what that's called, when we're multiplying a binomial by an exponent here. Okay, so notice that the coefficients of the variables in the final product of a plus b, all right, that's what these coefficients are, okay, are the numbers from the third row, in this case, because it says a plus b, of Pascal's triangle. So we would look at this third row, and we can look at all the coefficients, and here they are. What notice this is a 1, 3, 3, 1, and notice it's the same thing, 1, 3, 3, 1. And then the coefficients say on a plus b to the fourth power, 1, 4, 6, 4, 1. And here they are. I'm going to put it in a different color so you can see it better. I'll just actually highlight it. 1, 4, 6, 4, 1. And notice on the last one, I'll do it in green, this is a plus b to the fifth power. We have 1, 1, 5, 10, 10, 5, and then back to our 1 again. And this is going to be true for all of our problems that we do. So this is going to be very helpful in helping us solve some equations. Okay, so each row of Pascal's triangle gives a coefficient of the corresponding binomial expansion. The pattern in the table can be extended to apply to the expansion of any binomial of the form a plus b to the n power, where n is a whole number. So this Pascal's table is going to come in really handy and help us to get some work done, so we don't have to do quite as much as we did way up here when we did x plus 4 to the fourth power. So we're going to find a shortcut here is what we're actually going to find. All right, so let's look at a few little things just to remember when we're using our shortcut. For a binomial expansion in the form a plus b to the n power, the following statements are true. There are n plus 1 terms. So what does that mean? Well, the n is the exponent, and n plus 1 is the number of terms. Let's see, look at our example here. A plus b to the 4 power. So that's our n is 4. 4 plus 1 is 5. So that means there should be 5 terms. 1, 2, 3, 4, 5. Awesome. Okay. So we know that there's going to be 5 terms if it's n to the 4th power. All right. The coefficients are the numbers of the nth row of Pascal's triangle. So if this is our row 0, this is 0 because remember that was to the 0 power. Row 1, row 2, row 3, row 4, oops, 4, this was 3, and row 5, okay? So each n, this is the only place you have to be careful that this starts out at the 0 row, okay? So that's the 0 row there. And notice that, like in row 5, we actually have 5 plus 1, 6, 1, 2, 3, 4, 5, 6. Okay, next, the exponent is a is n in the first term, and the exponent decreases by 1 each successive term. So notice a to the 4th power, it starts out at the 4th power, and then a decreases by 1. So 4, 3, a to the 2nd power, a to the 1st power, and our last one is actually a to the 0 power, but we don't put that in because it's just an understood 1. All right, and then the b, the exponent of b is 0 in the first time, and the exponent increases by 1 in each successive term. So here's our b, it's going to increase. So here in the first one it's b to the 0, which is understood 1, b to the 1, b to the 2, b to the 3, and b to the 4. All right, and the sum of the exponents in any term is n. So notice 0 plus 4, I'll do this in a different color, 0 plus 4 is 4. 3 plus 1 is 4. 2 plus 2 is 4. 3 plus 1 and 4 plus 0. So each of those are also going to be 4. All right, so let's just look at our example problem that we had and just see how that works out. Notice our x is going to be the a and our 4 is going to be the b. All right, so here we have x to the 4th. I'm just going to clean this up a little bit again so we can see it all. Okay, so this following our pattern, it says the first one is going to be a to the 4th power. So x to the 4th power, there it is. The next one says take 4 times, okay, a to the 3rd power, so that's our x to the 3rd, and b, so we just have regular 4 times 4 is 16, so there's our second number. All right, the next one says take 6 times, okay, a squared, so that's our x squared, b squared, 4 squared is 16 times 6 is 96. And our next one is going to say, okay, we're going to take 4, but we're going to multiply it times a, and our a is our x, so there's that. B to the 3rd, so that's 4 times 4 times 4 is 64, times 4 more is 256. And then our final says just b squared, b to the 4th, and b to the 4th is again 4 times 4 times 4 times 4, which is 256. And this works out every time, so if you follow all the rules, it's one easy way. So let's do some problems like this. Okay, so this example, it says k minus 5 to the 3rd power, and we're supposed to expand each expression. So before we would just write it all out and distribute everything, and now we're going to try it a little bit easier. So first of all, we want to look at our n power, which is n to the 3rd. So we're going to look over at Pascal's triangle. Remember, this is 0, 1, 2, 3. So our third row says 1, 3, 3, 1. So I'm going to go ahead and put that in. 1, 3, 3, 1. And I went ahead and spread them out because I've got a lot to go in there. All right, so our k is a, and negative 5 is going to be our b. So let's go ahead and write k and negative 5 in each place. K, negative 5. K, negative 5. K, negative 5. And k times negative 5. All right, I'm going to put my pluses in here. Now, remember it said that the number of terms should be 3 plus 1, which is 4. So we do indeed have 4 terms. All right, so now we have to get our a's and b's, the exponents on our a's and b's put in. So remember, our a starts at 3 and goes down. 3, 2, 1, 0. And our b starts at 0 and goes up. 0, 1, 2, 3. Okay, so now I've just about done everything. I just need to simplify and multiply everything out. So 1 times k to the 3rd times negative 5 to the 0 power. Remember, negative 5 to the 0 power is 1. So that is just k to the 3rd power. Plus 3 times negative 5 to the 1st power, which is negative 5, is going to be a negative 15 k squared, plus negative 5 times negative 5 is 25 times 3 is 75k, plus k to the 0 power is 1 times 1 is 1, and then we just have negative 5 times negative 5 times negative 5, which is negative 125. So our final answer then is k to the 3rd plus a negative 15k squared plus 75k minus 125. All right, let's try the next problem. Again, we see that we have a third. It's going to go to the 3rd power, so it's going to be 1, 3, 3, 1. And this is our A, and this is our B. So we're going to go ahead and put our A's and B's in there. 6m times negative 8. All right, 6m times negative 8. times negative 8. Okay, so now we have it, and we go ahead and put our plus signs in between everything. Now remember, our a's are going to start out with 3, so we're going to do that to the third power, second power, first power, 0 power. And our b's start at 0, and they go up 1, 2, and 3. Now we're almost finished. Now we just have to simplify everything. So the first one we see is 1 times 6m to the third. Okay, so 6 times 6 is 36 times 6 is 216. But then we also have to multiply times the negative 8 to the 0 power, which is 1. So that first one is going to be 216m to the third power. All right, now the next one we have is 6 times 6 is 36 times 3 times negative 8 actually ends up to be negative 864, and that's going to be m squared. All right, the next one's going to get even larger here. We have to say negative 8 squared is positive 64 times 6 times 3 is actually 1,152, and we just have one m there. And then our final is going to be 6m to the 0 power is 1 times 1, and then negative 8 times negative 8 times negative 8 ends up being negative 512. And so there is your final answer. All right, I hope you understood how to do that. So you're going to try a couple of on your own. Turn the video off and try these on your own. Okay, hope you were able to figure those out without too many problems. Let's look at the first one. Our exponent is 3, so we're going to count down 3 rows. 0, 1, 2, 3. All right, so it's 1, 3, 3, 1 again. 1, 3, 3, 1. All right, x is a and b is going to be 2, so we're going to say x2, 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 and x and 2. All right, next we want to go ahead and put our exponents on. So this is going to be, on the a is going to be 3, 2, 1, 0. And our b starts at 0, 1, 2, 3. All right, so here we have x to the third power times 1 is just x to the third power. And then we have 3 times 2 to the 1 power is 2 times 3 is 6x squared. So 6x squared. And then 2 times squared is 4 times 3 is 12x. And then now we have no x's. 2 times 2 is 4 times 2 is 8 plus 8. So there is our answer. I wrote it awfully big there, but you can see it clearly. All right, and the last one is exponent is 5. So we have to go to the 5 pile. And that is going to be 1. I'm going to spread it out. 5, 10, 10, 5, 1. All right, and now our x is a and our b is negative 4. Sorry, our b is going to be negative 4, but that's our b. All right, so I'm going to go ahead and put x and negative 4 in every slot. X, negative 4. Hope you're able to follow through all this. It's not near as time consuming as if we had worked it all the way out. So it's quite a good shortcut here. All right, so now what exponent do we start out with for our a's? It's going to be 5. So we're going to say 5, 4, 3, 2, 1. Oh, I left one out. X and negative 4. And that's a 0. And then our b's are going to start out with 0 and go up 1, 2, 3, 4, 5. Okay, now all we have to do is multiply everything through. And so we see negative 4 to the 0 power is 1. So this one just ends up being x to the 5th power. Negative 4 times 5 is negative 20. So we have minus 20, x to the fourth power. All right, -4 times -4 is positive 16 times 10 is a positive 160 x to the third power. All right, and now we're getting really big. Let's see, this is actually going to be negative 640. Negative 640 x squared. And now we're back to the easier ones. Well, no, 4 to the fourth power is 256 or something, but times 5 ends up making it 1,280x. And then the last one is going to be -4 to the fifth power, which is a negative 1024. So here is your final answer, and I hope that you were able to figure that out on your own. If not, now you can. All right, and I think we have one last problem. All right, so here's one more for you to try on your own. Turn your video off and give it a try. Okay, so I hope that when you looked at this and saw that there wasn't a table up here, that you were able to just kind of make your own chart on your own. So let's go through this really fast and make sure that you can do it. The first number is going to be 1. So we have 1 and then 1 and 1, because 1 plus 0 is 1 and 1 plus 0 is 1. Now we'll add these two together. 1 plus 1 is 2, and our 1's just come down. All right, and now we have 1 plus 2 is 3, and 2 plus 1 is 3, and our 1's just come down because 1 plus 0 is 1. All right, and then we'll do it again. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and our 1's come down. All right, so this says that we're to the fourth power, so this is 0. This row is 1. This row is 2. This row will be our third, and this last row will be our fourth. All right, so we're going to have 1, 4, 6, 4, 1. So I'm going to go ahead and put these up pretty far apart. 1, 4, 6, 4, and 1. All right, now here's my A and here's my B. So I'm going to go ahead and fill my A's and B's in. 3x times 1. 3x times 1. 3x times 1, 3x times 1, and 3x times 1. And really, I didn't need to put my 1's in there, but just for the sake of doing it, it's good practice. And there's pluses all in between here. All right, so let's go ahead and go for it. Remember, our A is going to start out with the power of 4, 3, 2, 1, 0. And our B starts with 0 and goes up. Now we could just multiply everything together. 3 to the fourth power is 81 x to the fourth. 81 x to the fourth. Plus 3 to the third power is 27 times 4 is 108. 108 x to the third power. Plus 9 times 6 is 54 x squared. Plus 3 times 1 is 3 times 4 is 12. So it's 12x, and then 1 to the third, of course, is 1. And then finally, 3 to the 0 power is 1, and 1 to the fourth power is 1. 1 times 1 is 1. And so here is your final answer. Much, much quicker than trying to multiply that entire thing out. So I hope you're really amazed by how orderly God has created our numbers and how there's so many new things that we can learn about the order of numbers and different things. When we study Blaise Pascal's triangle, he was also a theologian and really had a lot of quotes and things that he said that are very memorable. If you ever want to look it up, you can read about him. One of the things he said that I thought was interesting is the knowledge of God is very far from the love of him. So I hope that you might take some time and contemplate either the amazing orderliness of God's creation and how he ordered our numbers, or even just Mr. Pascal's quote on the knowledge of God is very far from the love of him, and exactly what that might mean. So I hope you have a great day, and I'll see you in class.